Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we have been provided with a 3D isometric projection of the solid into which the front view face, the top view face and the right hand side view face, they have been appropriately combined into a single 3D isometric projection. So using the information available with us through the 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of the solid. So in order to obtain the orthographic projections of the solid, we need to obtain the dimensions of the front view face, top view face and the right hand side view face of the solid. So as we are going to look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 120 millimeter, while the height of the solid happens to be equal to 60 millimeter. So the front view face, it is going to have dimensions 120 millimeter width and 60 millimeter height of the solid. When we are going to look at the solid from the top view orientation, so we observe that width of the solid happens to be equal to 120 millimeter, while the depth of the solid happens to be equal to 80 millimeter. So the top view face of the solid, it is going to measure 120 millimeter by 80 millimeter. When we are going to look at the solid from the right hand side view orientation, so we observe that the depth of the solid happens to be equal to 80 millimeter, while the height of the solid happens to be equal to 60 millimeter. So we are going to obtain the dimensions of the side view face as 80 millimeter by 60 millimeter. So with this information, we are going to evaluate the orthographic projections of this engineering object. So now, in order to obtain the orthographic projections of the solid, we are going to draw the XY reference line, the X1, Y1 reference line and a transfer line which is originating from the intersection of the XY reference line and the X1, Y1 reference line, which is inclined at an angle of 45 degree with respect to the XY reference line. And this transfer line we are going to use in order to transfer the distances alongside the depth of the solid into the top view projections, into the right hand side view projections over here. Now since we are going to obtain the orthographic projections of the solid into the first angle projection method, so the front view orthographic projections will be obtained above the XY reference line. The top view orthographic projections of the solid will be obtained below the XY reference line, and the right hand side view orthographic projections of the solid will be obtained onto the left hand side of the front view projections above the XY reference line over here. So we know that the dimensions of the front view face of the solid, it will be measuring 120 millimeter width and 60 millimeter height. So we have marked the width of the solid equal to 120 millimeter into the front view projections by drawing two vertical projector lines which are separated by the distance 120 millimeter, which is equal to the width of the solid. And these two vertical projector lines we have appropriately extended into the top view projections, because into the top view projections also we are going to require width of the solid equal to 120 millimeter. Now we know that into the front view projections, the height of the solid happens to be 60 millimeter. So we have marked this height of the solid equal to 60 millimeter into the front view projections by drawing a horizontal projector line at a height of 60 millimeter from the XY reference line, and this horizontal projector line we have extended into the right hand side view projection view, because into the right hand side view projections also we are going to require height of the solid equal to 60 millimeter over here. Now into the top view projections, we know that the width of the solid happens to be 120 millimeter, which we have already obtained through these two vertical projectors which we had obtained into the front view projections over here. But the depth of the solid now we need to evaluate into the top view projections over here. So now we have drawn two horizontal projector lines over here into the top view projections, which are separated by the distance equal to 80 millimeter, which is corresponding to the depth of the solid over here. And these two horizontal projector lines, we have appropriately transferred them into the right hand side view projections, such that into the right hand side view projections as well, the depth of the solid equal to 80 millimeter we have been able to obtain over here. And we have already obtained the height of the solid into the right hand side view projections as 60 millimeter. So the front view face, the top view face and the right hand side view face of the solid, they have been appropriately located into the orthographic projections over here. Now when we look at the constructional details of the solid, so we observe that now this solid comprises of a rectangular block into which different cut sections they have been provided over here. So here we have got cut section number 1, which is corresponding to this element number 1 we can call, which is a circular cut section which is perpendicular to the front face of the solid. So this element number 1, it is a circular cut section which has been provided towards the left hand side face of the solid over here. And this circular cut section lies perpendicular to the front face of the solid. Then we have got the second segment over here. So this second element, it is once again a circular cut section, but now the difference between circular cut section number 1 and the circular cut section number 2 is that into the second circular cut section, which is provided alongside the front face of the solid, and the circular cut section is having radius is equal to 45 millimeter. Now we have got element number 3, which is a vertical wave, and now this vertical wave, it is having two flat surfaces which are inclined at an angle of 90 degree with respect to each other. So this is our element number 4 over here, which happens to be an inclined surface over here. This vertical wave we can check, it was parallel to the front face of the solid over here. So this way, this was element number 1, this was element number 2, this is element number 3, and this is element number 4, which is an inclined surface. Then we have got an element number 5, which happens to be a horizontal wave which is located towards the right hand side portion of the solid. So as we are going to look at the solid from the front view orientation, so now we can check. This is a flat surface into this rectangular block front face which is available over here, and the height of this flat surface onto the front side of this object, it is equal to 30 millimeter. So now we have marked a distance of 30 millimeter from the base of the solid, and we have obtained a horizontal projector line into the front view projections, and this horizontal projector line we have extended into the right hand side view projections as well. Now we know that corresponding to this remaining height of 30 millimeter, so this element number 2, it is a circular cut section which is having radius equal to 30 millimeter. So corresponding to this radius of 30 millimeter from the top surface of the solid, so this distance is also equal to 30 millimeter. So now we know that corresponding to this element, the width of the circular cut section, it happens to be 25 millimeter from the left hand side face of the solid. So from the left hand side face of the solid, we have marked a vertical projector line into the front view projections at a distance of 25 millimeter from the left hand side face of the solid, and this vertical projector line we have extended into the top view projections as well. Now with this we have been able to obtain the apparent shape projections corresponding to this circular cut section which happens to be perpendicular to the front face of the solid into the front view projections over here. Therefore, this circular cross section will be visible to the observer into the front view projections as an apparent shape rectangular projections over here. Now, there is another circular cut section available over here which is aligned with the front face of the solid, and it is parallel to the front face of the solid, having radius is equal to 45 millimeter. But this circular cut section, it is going to start at a distance of another 20 millimeter from the left hand side face of the solid. So now we have marked this distance of 20 millimeter from the left hand side face of the solid, starting from this vertical face of this circular cut section over here. So from this edge we have marked a distance of 20 millimeters so that the starting point of the circular cut section parallel to the front face of the solid can be obtained, or the starting point of this inclined surface which is our element number 2, it will be obtained into the front view projections over here. So our slant portion corresponding to this rectangular inclined surface, it will be starting from this point over here, from the top surface of the solid. Now having obtained this point, now we know that this distance happens to be 45 millimeter. That is, this vertical web which is our element number 3, it is having width is equal to 45 millimeter corresponding to the top surface of the solid, and it is having height is equal to 45 millimeter which is measured perpendicular to the base of the solid. So this way we are going to obtain this distance over here as 45 millimeter. So at a distance of 45 millimeter from this edge over here, we have been able to evaluate a vertical projector line into the front view projections, and this vertical projector line we have been able to transfer into the top view projections as well. So now we can check that this will be our starting point corresponding to this circular arc over here, that is the center of the arc will be located over here. So now the starting point of the arc we have been able to locate corresponding to this point onto the top surface of this particular rectangular block over here. Now another thing we know that this flat element which is our element number 5, it is having width is equal to 30 millimeter. So we have marked this width is equal to 30 millimeter which is corresponding to the remaining surface of the solid which is available towards the right hand side portion of this solid over here. Now we also know that onto this horizontal web, so at a distance of 15 millimeter from the right hand side face, we have been able to obtain the center point corresponding to the circular hole having radius is equal to 10 millimeter or diameter is equal to 20 millimeter. So from the right hand side face of the solid, we have marked a vertical center projector line corresponding to the center of the circle at a distance of 15 millimeter from the right hand side face of the solid, and this vertical center projector line obtained in the front view projections has been transferred appropriately into the top view projections as well. Now having obtained the center line, we know that the radius of the circular hole, it happens to be equal to 10 millimeter. So corresponding to these two diameter points over here, extreme point of diameter over here and over here. Now we need to obtain an offset of 10 millimeter on the left side and 10 millimeter on the right hand side of this center line, so that the projector lines corresponding to the diameter equal to 20 millimeter can be obtained into the front view projections and into the top view projections as well. Now we know that the height of this element number 5, that is the horizontal web, above the ground happens to be 15 millimeter. So 15 millimeter above the ground, we have marked a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projections as well. Now we know that this is going to be our starting point, that is this point. It is going to be our starting point corresponding to this circular cut section, which is having radius is equal to 45 millimeter. So with this as the center point, we know that this is radius is equal to 45 because this distance is 15. So the remainder distance is 45 millimeter. Again, this distance is also 45 millimeter. So with this point or this point as the center, radius is equal to 45 millimeter. We are going to draw the circular projection corresponding to this circular cut section, which we are able to observe onto the front side of the solid over here. Next, whenever we are going to look at the solid from the front, so this vertical edge will be visible to the observer. This horizontal edge, it will again be visible to the observer, and this vertical edge, it will also be visible to the observer, and this flat surface will be visible to the observer as an edge view, and this arc will also be visible to the observer over here. Now another thing we can check, that this portion and this portion, it will also be visible to the observer. So now we have marked the boundary of the solid over here. Another thing we have already discussed, that corresponding to this circular cut section which happens to be perpendicular to the front face of the solid, we are not going to observe true shape projections corresponding to the circular cut section. Rather, we are going to obtain apparent shape rectangular projections corresponding to this circular cut section, which is our element number 1, which is perpendicular to the front face or which is aligned with respect to the left hand side face of the solid. And another thing we observe over here, that corresponding to this inclined surface, starting point we have already discussed, this will be our starting point at a distance of 45 millimeter from the left hand side face at the top surface, and at the bottom it will be at a distance of 30 millimeter from the right hand side face, we can check, and at a height of 15 millimeter from the base. This is the projection of the inclined surface which is not visible to the observer from the front view orientation, because this inclined surface happens to be overshadowed or covered by this vertical web over here, right? So this way we have been able to obtain edge view projections corresponding to this inclined rectangular surface, a hidden line projections into the front view projections over here. Another thing we should observe over here into the front view projections, since this surface which is shown over here into the front face of the solid, so since this surface happens to be parallel to the vertical plane, so its projections onto the vertical plane will be represented as true shape projections into the front view projections over here. So these projections, they are true shape projections represented into the front view projection. Similarly, corresponding to this front face of the vertical web, which is our element number 3. So this face is also parallel to the vertical plane. So into the front view projections, we are able to observe true shape projections corresponding to the front face of the vertical web over here. Further, this circular hole, it is not visible to the observer from the front view orientation. So corresponding to these two diameter extreme points, we have been able to obtain the hidden line projections into the front view projections of the element number 5 over here, which is the horizontal web, which is located towards the right hand side portion of the solid over here. Now let us proceed to evaluate the top view projections of the solid. Now we can check, as we are going to look at the solid from the top. So from the rear face, we observe that the depth of this inclined rectangular web from the rear face of the solid, it happens to be equal to 35 millimeter. So we have marked a distance of 35 millimeter from the rear face of the solid and obtained a horizontal projector line into the top view projections, and this horizontal projector line we have transferred it appropriately into the right hand side view projections using this transfer line over here. Next we have got this vertical web. So we know that the depth of this vertical web, it is going to be 25 millimeter in front of this inclined rectangular web over here. That is, now we are going to measure a distance of 60 millimeter from the rear face or 25 millimeter from this point of the inclined rectangular web over here. So now we are able to mark another horizontal projector line corresponding to this vertical face of the vertical web over here, which is our element number 3. So now we have obtained a horizontal projector line into the top view projections and we have transferred this horizontal projector line appropriately into the right hand side view projections using this transfer line over here. Another thing we know that the center point corresponding to the circular hole which is located into the element number 5, that is the horizontal web, it happens to be 15 millimeter from the front face of the solid. So this is the front face of the solid. So from the front face of the solid, we have marked a distance of 15 millimeter and a horizontal center line projection we have obtained, and we have transferred this horizontal center projection line into the right hand side view projections over here. And we also know that the radius of the circular hole which is obtained into this horizontal web, it is equal to 10 millimeter, so that the diameter will be 20 millimeter. So with respect to this horizontal central line into the top view projections, now we are going to take 10 millimeter offset towards the rear side of the solid, 10 millimeter offset towards the front side of the solid with respect to the center line, and this diameter corresponding to these two extreme points of the diameter of the circular slot we have been able to obtain over here. Therefore, two horizontal black projector lines we have been able to mark separated by a distance of 20 millimeter corresponding to the diameter of the circular slot into the top view projections, and these two black horizontal projector lines corresponding to the circular cross section we have appropriately transferred into the right hand side view projections as well. And having obtained the center point location, now we have obtained the top view true shape projections corresponding to this circular hole over here, which happens to lie into this horizontal web, that is element number 5, having radius is equal to 10 millimeter. Now we also know that corresponding to this circular cut section, which is our element number 1, which is perpendicular to the front face of the solid, it is having radius is equal to 30 millimeter. So from the front face of the solid, this radius we are going to measure as 30 millimeter. So this is the front face of the solid. So from the front face of the solid, we are going to measure this radius as 30 millimeter, and at a distance of 30 millimeter from the front face, we have drawn a horizontal projector line into the top view projections, and we have transferred this horizontal projector line appropriately into the right hand side view projections over here. So let us start joining various edges of the solid which are visible to the observer from the top view orientation. As the observer is going to look at the solid from the top, we can check this cross section, that is the boundary of the solid. It will be visible to the observer from the top. So to begin with, we have joined the boundary of the solid corresponding to the different elements of the solid over here. Next, we have got this circular cut section which is perpendicular to the front face of the solid, and we have already discussed that this circular cut section will be obtained as a rectangular projection which will be represented as an apparent shape rectangular projection into the top view projections over here. So this is the apparent shape rectangular projection corresponding to the circular cut section which happens to be perpendicular with respect to the front face of the solid. So now next we have got this inclined surface over here which is lying towards the rear side of the solid. So we can check that this rectangular surface happens to be inclined with respect to the horizontal plane. Therefore, onto the horizontal plane in the top view projections, we are going to obtain the apparent shape projections corresponding to this inclined rectangular surface which is lying towards the rear side of the solid over here. And now corresponding to this flat surface of the vertical wave, we are able to witness the true shape projections into the top view projections over here. So, and we also observe that this total portion which is lying at the top surface of the solid, it happens to be parallel to the horizontal plane. So that is why into the top view projections, so this projection of the top surface of the solid will be obtained as a true shape projection over here. And another thing we can check, corresponding to this top surface of the horizontal wave, we are able to witness true shape projections into the top view projections over here. Whereas corresponding to this circular cut section which happens to be parallel to the front face of the solid, we are not able to obtain true shape projections in the top view projections over here. So into the top view, we are able to obtain only the apparent shape projections corresponding to this circular cut section which happens to be parallel to the front face of the solid. Let us now proceed to evaluate the right hand side view projections of the solid. So when the observer is going to look at the solid from the right hand side view, so this vertical surface which is a rectangular surface parallel to the profile plane, so this surface will be projected as true shape projection into the right hand side view projections over here, and we will be able to witness the boundary of the solid into the right hand side view projections over here. And another thing we can witness over here, that this circular hole, it is not visible to the observer from the right hand side view. So these two extreme points corresponding to the diameter we have already evaluated into this horizontal wave. So we will be able to obtain the dotted line projections or the hidden line projections corresponding to this circular hole into this horizontal wave which is having height is equal to 15 millimeter. Next we have got this inclined rectangular surface. So since this rectangular surface happens to be inclined with respect to the profile plane as well, so the projections of this inclined rectangular surface onto the profile plane will be obtained as apparent shape rectangular projections into the right hand side view projections over here. So these are apparent shape projections corresponding to the inclined surface, which is our element number 4 over here. Similarly, corresponding to this vertical web, now this rectangular surface happens to be parallel to the profile plane. So we are able to obtain the true shape projections corresponding to this element number 3, which happens to be a vertical web over here, and corresponding to this circular cut section over here into the right hand side view projections. Once again, we will be able to obtain a rectangular apparent shape projections into the right hand side view projections over here. So these projections, they will be obtained as rectangular apparent shape projections corresponding to the circular cut section or a circular slot, which happens to be parallel to the front surface of the solid over here. And finally, corresponding to this circular cut section, which happens to be parallel with respect to the left hand side face or perpendicular to the front face of the solid, we are going to obtain true shape projections corresponding to the circular surface with respect to this point over here. So this will be the point of the radius over here. So with this point as the radius, we are going to take radius is equal to 30 millimeter, and a circular projection we have been able to obtain into the right hand side view projections, which are going to represent this circular cut section, which is perpendicular to the front face or parallel to the left hand side view face of the solid. And since the circular cut section is parallel to the left hand side face of the solid, so from the right hand side view projections, we will be able to obtain true shape projections corresponding to the circular surface over here. But this circular surface is not visible to the observer from the right hand side view because it has been covered by this circular portion and this flat portion over there. So we will be able to obtain the hidden line projections corresponding to the circular cut section, which is perpendicular to the front face or parallel to the left hand side face of the solid. So this way we have been able to obtain the orthographic front view projections, the orthographic top view projections, and the orthographic right hand side view projections of the solid, corresponding to which we had been provided with 3D isometric projections of the solid. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.